All right, number 19. This is one of the lesser satisfying questions. I'll show the answer, but long story short, I had to ask the Qiskit Slack channel for help on this one. So heads up, Qiskit Slack channel, super friendly, really recommend it. People there are great. But the answer for this one, so number 19. What would be the fidelity results for these two operators which differ only by global phase? And then we have some stuff here. It sets it up. It does things with these operations, these methods, and with these parameters. So we have some stuff of the similar flavor going on. So we'll underline the stuff that's similar flavor. So these are operations that are being performed. We call them methods, but they're all operations. These are all trying to do the same thing. Everything in purple is trying, not that, I shouldn't say that. They're not all trying to do the same thing, but the idea behind them is similar. They're methods. We're doing these things with these parameters. Okay. So the trick to this problem and the answer, ends up being that one of these in the group doesn't play nicely with our parameters. State fidelity doesn't work with operators is the main thing, but one of these things we're doing, the purple underlined things, the methods, the things the methods we're running, doesn't play friendly with this class called an operator. So it's just not playing friendly. So it's just a matter of knowing what plays nicely with other, what plays nicely with each other. So we'll delve into this in a second. But it's one of the lesser satisfying answers because it's just like you kind of know it or you don't. So here we see the Qiskit API. Well, let me just go back to this real quick. So there's the answers are kind of bland compared to others because it's kind of just state fidelity doesn't work with operators, and you see us try to do different things. One of them being state fidelity, another one of them being average gate fidelity, and just another one is process fidelity, right? Just same types of things, but different names, right? And to get us different results because we're interested in different things. So state fidelity doesn't work with operators, but average gate fidelity and process fidelity do. That's kind of the crux of it here, but we'll explore a little bit here on the Qiskit API. So that's one I had to memorize. State fidelity doesn't work with operators. I just had to memorize that. So here we see, what we do when we have questions about this type of stuff. We type in Qiskit, the thing we're wondering about, and then API. So here I typed in, I don't know if I can zoom. Yeah, it looks pretty good. There we go. Qiskit state underscore fidelity API. And here are the results. So you can click on how many ever we want. They won't always give you what you're looking for, which we'll see in a second here. But we click this first one. They're already open, so I'll close them. Clicking this one, and then we'll stop here. This one is Stack Overflow. In the community of software, this is a good place to go if you have questions. I really recommend forums, and this is a great forum for software type questions. Okay. Stack Exchange, something similar just to Stack Overflow. Both great forums to reference. And here we have the Qiskit API. So this first one is the first link, I believe. And the second one, here we go. First link, second link. So first link, here's the more specific one. So we'll go that one second. But here's the operators for, it's technically under Terra. I think they renamed it to like machine learning or something like that. But we're going to do Control F. Let's see here. What are we looking for? Qiskit? No. State underscore fidelity. Okay, we have it here. We have two parameters, two inputs, right? State 1 and state 2. And this is a possible variation on state 2 that we can enable or disable if we want to validate something. So what does state fidelity do? It returns the state fidelity between two quantum states. So we're going to click this. I believe it's going to be the same page as the other one. So click this. They should be the same if we go back and forth quickly. So here's page 1, page 2. Oh, let's match them. Page 1, page 2. Okay, they're the same. Okay, so here we have state underscore fidelity. And we want to see what it says here. It says it returns the state fidelity between two quantum states. And again, there's when the lesser satisfying questions, because even myself, I couldn't find it no matter how much I sifted through dirt to find the gold nuggets. I couldn't find this gold nugget. I don't understand why. It doesn't, I'm probably missing something. It doesn't appear on first glance to be in this documentation, so we'll see real quick. Return the state fidelity between two quantum states. The state fidelity F for density matrix input states P1, P2 is given by this function. If one of the states is a pure state, this simplifies to this, where this, and then these bracket notation, there's equal to this, these two states. This state, this description of, whatever, one state, parameters, the first quantum state, it doesn't mention anything about, this question. But I think it could be an oversight on my part, because I think it's a fundamental software thing about methods and operators playing nice with each other, and not necessarily a Qiskit problem. So it might be more of an embedded problem that I realize. So it might be something on me, and I wouldn't be surprised if it is. But yeah, long story short, there's one of the lesser satisfying questions. 19. What would the fidelity result for these two operators, which differ only by global phase? This is the one this is one of the ones I had to memorize. It's just that you have to know that state fidelity does not work with operators. I got this answer because I went to the Slack channel and I asked this question because I couldn't find the answer online, and they explained to me, someone that designed helped design the exam was like, state fidelity does not work with operators. I was like, okay, thank you. So yeah, that's why C is the answer, because it is the option that does not use or include state underscore fidelity. Option C, average gate fidelity and process fidelity. All right, there's no state fidelity there, but the other ones all include state fidelity. So having to search through to find the answer online. But yeah, the answer there is C, and it's because state underscore fidelity does not work with operators.